So my name is Oscar Brück. I'm a medical doctor and have been working with the HUS Data Lake and with the analysis in the academic environment now for 4 years. First of all, how to access the academic environment. There are very good instructions prepared by the HUS IT. And the way to go is basically to use the Citrix application. And there's 2 ways to do that. One way is by the browser, and the other one is by downloading the application. I warmly recommend to download the application. There are less delays, and there are also less technical problems with the application than with the browser. So after you have connected to the HUS environment and making sure that you have logged in with your HUS Data Lake username, you should be able to see the different academic environments you have access to. And today I'll do the demo on this academic environment where I mostly work. So I won't change this as it is already active. If you would like to change this, well, there are very good instructions. So basically, you can just click on any of the other ones. You need to wait about 5 minutes, and by looking at the feed, you should see then that the environment has changed, and you should log out and then log in back. But now we can just...
Oscar, can I interrupt you, please? So
yes.
I haven't logged into this new environment since the last time, so I'm also new.
Okay.
So this mobile duo application, so is it, what is, can you show me online, or if it's this mobile application?
So there are both instructions in English and in Finnish.
If you wait, or if you send that.
Yes, I can send that to you.
Okay.
Those who have access to the HUS SharePoint, so you will need to have the HUS username. You can just go to the HUS SharePoint and search for HUS Acamedic ohjeet or HUS academic instructions. So get those. And if you don't have that, you can always send an email to acamedic@hus.fi, and they'll give you the most recent instructions.
Okay.
So basically, there is a link that is available to everyone, but I'm not sure if you can kind of search for that link just by Googling it, as it is reflected from the HUS servers. But basically, you have access to that, but also from outside. But it might be difficult to find. Yeah.
Okay.
All right, and then you have in each environment, to my knowledge, there is the possibility to log in through 3 different virtual desktops or 3 different virtual computers. The Linux and Windows desktop, basically, they don't have any difference between them. If you're more used to use Linux, go ahead with that. If you're more used to use Windows, just go ahead with that. But they have the exact same functionalities. The only difference is basically that if you would like to use the command line then if you're more used to use the terminal, then Linux, or then the command prompt, then Windows. The actual virtual machines here are not that powerful. They are good if you want to do some basic data analysis. But if you would like to do some model development or if you would like to read larger data files into the memory, then it is not advisable to use these virtual machines. However, in each of the 3 different virtual machines, you have the possibility to create a computing instance. So basically a virtual machine inside a virtual machine. And there you can configure it so that it has more RAM memory, so basically more power to do any analysis. Or if you would like to have some graphical processing units, it's also possible to add them there. So basically you can choose any of these three. However, I mostly use this HP Linux for the reason that this virtual machine here is a bit more powerful than these two. It has 8 cores, and I think the memory is about 32 gigabytes. And one thing why I like to use this HP Linux virtual machine and not the virtual machine that is created inside of this is that it has the RStudio IDE that I can use. So you cannot use the RStudio within the virtual machine that is created inside this, so the Azure machine learning instance. I'll show you what that means. But so the only way to use RStudio with large data files is basically by activating this HP Linux. So I'll show, and they don't have any difference in the how they look like these desktops. So I'll just activate this so you see how it looks like. So what happens? It creates the Citrix viewer. At the moment, there are no private directories inside here. So anything you create, anything you do is all the other researchers in that study permit can see that. So all the researchers that have access to the environment can see what you do. However, this will change now at the moment, to my knowledge, in June, so 2023. And there would be private directories where you can store results, scripts, whatever, if you would like to do so. The basic structure is that there are 3 mounted directories. Obviously, import is the place where HUS IT will import the data to the environment, and you have only reading permissions to these files. So you cannot save there anything. You can only read the files from there. And you cannot edit the files either. So what it looks like is within the import, there is an other import file. And there you can see different directories that differ, that are named based on the date they have been imported to the environment. And each time there is a new import, whatever data that is, it will create a new directory. We have been discussing that this is not really maintainable. It's quite confusing for new researchers to find data that they're interested in. So this will be probably rearranged. And what I would suggest is that this will be emptied every month, and all the the recent files will be stored in the research network. So the research directory, and here the difference is that this is complete. You have all permissions here. You can read, you can write, and you can execute any file. So you can see this is all that I have created here. So anybody that has access to this environment can they can delete everything. I hope that nobody will do that. You can use any of the scripts there is here, any of the data that is here. And what I would hope to do is that we'll create a directory for the files that are the most recent for the import directory, and give the permission to HUS IT to delete every month then all the files that are here, so that it's easier for the researchers to navigate here. Then if you do any analysis and you want to export them to your own computer, you should leave them in this export directory and send a message to the HUS Tietolupa, so the HUS unit that is in charge of the data, basically transport in and out of the Acamedic environment. Before going to what kind of data or what kind of files there are here, let's have a look at what kind of softwares there are. So now this is the Linux version. So there are the Linux LibreOffice or Linux compatible versions of Word and Excel, for example, and PowerPoint. There are for if you want to do some statistical analysis, there is the RStudio. If you want to use Python, you can use the VS Code, Visual Studio Code. So what I've been doing in the environment at the moment is I have created kind of a custom settings so that every new researcher do not need to install their own packages, and to make sure that the system works as easily as possible. So every time you disconnect from the environment, anything that you have saved outside of the research will be deleted. So that means that every time you start, then you restart the connection here. RStudio will need to find the R profile file. So basically the settings that will tell it where your installed packages are, and where, for example, what is the cron mirror where to install them from. You have two options. One is that every time you open RStudio, define it manually. So you run basically a script, or you define it manually there where to find them. I don't like that option. So I have created kind of a pipeline to help this process. Just wait a moment. And if this kind of window appears, you can just click on cancel. This appears, and if every time you open Google Chrome, it will ask you this. You don't have any possibilities to basically change to send information to Google. So whatever you click, it's fine. Nothing will be sent. So basically, you have only access to very restricted URL addresses where you can install R packages, for example, but you don't have access to the open web. So this is a part of the data security of the Acamedic environment. So before going to the how to launch and how to use the RStudio, or maybe we can go to that now, and then I'll show you how the environment is created. So how I advise to use the RStudio is that you open, if you use the Linux, you open the terminal. If you use the just use the Linux HPs, it will be the most clearest one. So open the terminal, and the only thing you need to do is basically right mouse, so this, and then research src launch RStudio. So this will ensure that you have all the configurations ready. You will have access to pre-installed packages. You will have a clear location where the libraries will be installed and where they can be installed, and you won't need to do any extra configurations when you start the RStudio. It might seem a bit weird that this needs to be done, but it's basically related to the settings of the Acamedic environment. So it is created so that it will delete everything that is outside of the research directory. So basically, the only way to make sure that you have these configurations is to kind of either manually retype them or then launch the RStudio in the way I just showed you. And you will have those instructions as well, so you don't need to remember any of those commands. So then whatever you want to do, but what basically it does, it's, for example, it's if you want to have a look at where the packages are installed, so they will be installed here. So it will be the kind of the launching script defines that this is the place where to find the R packages. And this is the place basically that all the researchers in this academic environment can use these packages. And anybody can also update these or whatever. So it's try to do as simple as possible. But let's have a look at the structure of this academic environment. So some of these, let's look at the most important ones first. So it's definitely this HUS data lake folder. So here there are the data. So this is pre-processed data from the raw or the original data that is coming to the environment. I have a figure for that to show you what I mean, is that in the academic environment, so this green area where you work and you have access to, you get data from HUS IT. The data is coming from the main data lake, and depending on the data permit you have, you will get only certain kind of data sources, and you will only get the data of the patients that are part of your study permit. So meaning that the red data, let's say that it's the clinical visits of the patients, and the green data is the laboratory data. So you get those to the environment, but you don't get, in our case, for example, opera operation, so the data of the surgical operations. All right, you get those here. The problem with that is that if you want to analyze the medication data, you have about 8 different tables that you can analyze. Each of those tables have tens of different variables. And what they kind of represent is that one is for Chemokur, so a software to store oncological drugs. One is for Marela, so the HUS pharmacy system. One is for prescriptions, that is for patients leaving the hospital. One is for the drug ordinations is inside the hospital, and there is also one that gives information that what drug has been given at any time point. One is for the side effects, and so on. So either you can analyze all of those 8 different tables yourself, or you can use the one table that's been created that incorporates all the medication data. And this same happens for most of these different data sources. So I've tried to kind of make things a bit easier, so that there is one table for the measurements, one table for the procedures, and so on, so that it's to make sure that not everybody needs to do the same work over and over again. And this is kind of the idea of why I have tried to make this pipeline inside this academic environment. So here is where you can find the data. I mentioned that in the import directory, there is the raw data that is imported from the HUS IT. But inside the mount, there is also the research directory, where there is the HUS data lake folder. And here you can find then these processed data sources. And me and my team are using mostly these data sources. So let's have a look again where to find this. So it's in this HUS data lake, and then there is the data. And here there are, one is for the cancer drugs, one is for demographics, diagnosis, flow cytometry, which is actually empty at the moment, measurements, laboratory other drugs, pathology, patient journals, procedures, radiology, and clinical visits. What I have done as well is that I have also combined these. So as I mentioned that there is only one drug table. So the cancer drugs, other drugs are now separate. But if you open, see which one it was again. Here it's in Lääkitys Chemokur. So here there are both in RDS format and CSV format all the data that has combined the oncological drugs and all the other drugs. So basically, if you open all of these 9 files, you have all the drug data for about 100,000 hematological patients in a quite nice format. So it's a large table. So they're all identical in the sense that they all have the same, I don't remember, about 60 different variables. And it's a bit not that clever to store them in one file only. So I wanted to kind of partition them into files of 1 million rows. So you can open each of them, and the same are also for the, if you prefer CSV format. So let's say you want to have a look in Excel, or if you want to, actually, I'm not sure if Excel is able to open these, but if you basically would like to analyze them in CSV format, it's fine. And this the same is for each of the different data sources. I've also stored the kind of a temp data files. So if you want to just have a look at the non-oncological drugs, you can just open here, and you have the same here without the oncological drugs. Or if you just want to have a look at the oncological drugs, they are here. And again, there is one for the Chemokur system, one for the Marrow system, and then a combination of those two. I won't go that much into the details of how they differ, but basically these are 2 different systems. And if you would like to use oncological drugs, it is warmly advised to use both data sources. So this is the kind of a starting point of if you would like to do any analysis in this specific environment or in your environment, and you would like to, and we are discussing with HUS IT to make sure that all those scripts to create these kind of a data are available to everyone. So if you're working in a different environment, it might take some weeks to get those there, but if you're interested, you're able to recreate all of these data sources there as well. So all the data is here. What else? I mentioned about the R libraries. So where to find them? They are all here in this R folder. So I have prepared a list of about 700 different libraries that are relevant, that the HUS IT has made accessible, and all the libraries are, or almost all of them are also installed here. So the restrictions at the moment in the Acamedic are that you can install anything from CRAN and anything from Bioconductor. Although at this day, the SSL certificate for the Bioconductor has expired, but it should be renewed, and I assume that it will start working again maybe next week or the week after that. So if you see that you cannot install some package from CRAN or from Bioconductor, just report that to the HUS IT Acamedic team, and they will have a look if that has happened, because that might happen once every while. But you cannot.
Possible to install from GitHub using the.
Yeah, no, okay. That's not possible, unfortunately.
Not possible. Okay.
Yeah, but you can import your custom data here. So if you describe that you can make like you can order data there. So you can describe that you are importing a GitHub repository, and you can install it that way. There is also another option, which is that you can there is the Azure DevOps.
So the DevOps, so yes, that's what I mean. Yes.
So basically, you can it will make accessible so that you can install any basically GitHub package from there at some time point. I'm not sure when that will happen, but probably quite soon.
Okay, but the import route is like I have to provide the tar-zipped source of the package, then put it in the import directory. So how do I do that? So do I have to contact you?
Yes. So there is a. Let's have a look again how that goes. There is a website for that. Here, page 22. Let's have a look at that. So there is this tietoportaali, which you can open, and you can log in here, and you can log in basically with your HUS address or with your, to my knowledge, is the Suomi.fi authentication. So basically with your bank account.
Yes.
And there is the possibility there to you kind of need to define the environment. So the name of the environment, which is the which you can see in the Citrix application. So so here, this one.
Yes.
Then you'll need to define some basic information. There is a lot of, you don't need to fill in all the steps there, but and then you need to define where to find the data. If it's less than, was it 100 megabytes or 200 megabytes, you can just yeah. And then otherwise, I have used Funet, so the CSC service to so that they can download or just
okay.
Yeah. And then it will take a few days, sometimes a few weeks, and then if you're in a hurry, just you can define it there, and then it will be imported there. In terms of softwares, I have also, so for example, I have imported the Spark installation file, so that if you would like to use, if you're familiar with Spark computing, so it's basically, it helps to parallelize some scripts. You can use it with R, and there is actually a script. It's actually very simple. I can show, for example, an example script of how that works. Sorry, it's not there, it's here. So I have to remember just that where I have used it. Oh yeah. So basically, if you would like to do some if you want to parallelize the computing, I've made two functions ready, which you can call. One is for the Spark, and the other one is to use this do parallel package. And just if you run this, it will create a cluster where you can just start using that. Or if you want to use the Spark, you can call the Spark cluster. So where to find these? These are in the scripts. So these are in this research in the script folder, and they're here in our functions. There are just a few at the moment. One is for the, as I said, the parallel clustering. One is for Spark, and one is if you would like to write Parquet formatted files. At the moment, the only way to do that is actually by using the Python library, for example, the fast parquet library to do that. But I have made instructions there. So if you would like to use, for example, the parallel cluster analysis, you can double click here. You will open it here. So basically what it does is that it creates, you have 8 cores. So it will create a cluster with 7 cores. And then there is an example script how to use that. So if you want to, if you would like to, in this file, for example, or let's put it this at, oh yeah, let's see that it is. So if you would like to, you have this data frame. If you would like to split it into batches of 50,000 rows, this will kind of give instructions on how to analyze this by using this parallelized analysis. So it's basically the same as the for loop, but it parallelized the analysis. So it does it 7 times faster. And for the Spark, there is also, so it basically creates just a very simple cluster. And if you would like to, it's maybe a bit easier. So here, if you want to read some CSV or Parquet formatted files, it will do it kind of a bit faster by using the Spark backend. And you can do, for example, want to summarize how many different lab tests you have. So you kind of run the commands by using the deploy library, and then in the end you collect the results. And this is at the moment where the computing is done. And yeah, so this is just an example of how that works. We can, if you're interested, you can of course ask more about that, but there are quite good documentations available as well. So here are our libraries. Here is the Spark. There is nothing. Then here is the set the data. Here are some scripts that I have made, for example. I'm not sure if there's anything useful, but basically these are now located here. Probably when there will be the private folders, I will delete this kind of from here and move it to the private directories and store my files there. What we are doing at the hematology side is that we are creating so-called disease tables. So I'll get back to this image. So we're trying to create a harmonized kind of a one table where you have all the information of patients that have a certain disease or certain diagnosis. So instead of, again, recreating, so that all the researchers would need to recreate the analysis, we'll try to make something that will make things a bit faster. We'll have one table, for example, for patients that have acute myeloid leukemia, and we make sure that this is kind of the up-to-date data, that it has all the relevant clinical data that is needed for most analysis, and that is then available for the downstream projects. And
thank you,
yeah.
Oscar. I have still some questions. So if you remember, we are interested in this immunodeficiencies.
Yes.
And yeah, we have already from Saima a question, if I saw it in the chat. So Saima says she's unable to see the HUS data lake folder that you just showed us.
Yes, and the reason is that at the moment I have created this only in this one environment where you don't have access to. So I will, whenever I have time, I will do the same in the same environment where you have access. So it will be provided there.
Okay.
Yeah, it won't take.
And is it only? I mean, so when you do that, so if, for example, the Miranda data, if I remember,
so
how can we find it now if we?
Yes, so it will be located. It will be located here, and as there at the moment, what I didn't mention is that there is also a bit of an extra dimensions as the, for example, the Miranda data. So there is both the Miranda and the Apotti data. And this is for all the data, most of the data source is the same. So I need to combine this, and the data in those patient journals are actually quite challenging to combine, as these are really large data files. And even if I split them, I have had some challenges to combine the files, but it should be doable. And it will be then located in this patient journal folder, and I'll provide it there in the environment where you have access to as well.
Okay, so where should we expect to have access to this HUS data lake directory?
This data, well,
so the entire directory, this HUS data
yes.
lake is still not accessible to us, right?
Yeah, so you have access to the correct environment, but I haven't imported these files to the other scripts to that environment yet. Okay. So probably will take. I'll try to do it next week.
Okay, by next week, and and that means that we would also have this the older, because I remember the older names now, the Miranda and
yes,
all the other data. So we don't need to go to those, right? So because you have already pre-processed them into tables.
Yeah. So all the old files we had are located, and that you have already access now. So if you go to the import, it's the first folder. So the one in September.
From last year. Okay.
Yeah. You open Jupyter R server. You open home dir. There you see all the, please do not open anybody else's folder than your own. There are, unfortunately, we have no access to change this at the moment, but yes, open only this folder and your own home folder, whatever it is here. And here you should be able to see the same files, the same folders you have created in the old environment. So for example, here, if there is some Miranda data, it should be available here. It seems to be loading a bit now. So it's all in this, in the, yeah.
But would the script still work? Would they still have the access to, if a certain address to a certain data was used in the script?
If the data is here,
okay, the data is there. Okay.
Then you should, if you have some scripts that analyzes that, you should be, but please look that if you use the relative paths, it should work. If you have the absolute paths in the scripts, then you need to modify them. Yeah.
Okay.
So you can take a screenshot, or if you want to remember, so it's basically here. So all the data from the old environment are either here, and then we did a last import recently, but I asked to import only the from the directories that I know that there have been some changes. Actually, I imported also yours, so you can have a look. If you did any changes after September, you can actually use this one. So there is this AIC 790, and again home dir, and then you can open this one, and you have, if there are, it seems to be the same files here, but if you did any changes after September, please open this one, so you make sure that you have all the up-to-date data here.
So to comply with new changes that you mentioned that would come, so it's better for us to move these data to the to the research.
Yes, definitely. Yeah. I'll do anyway. Probably I will import these for everyone in a dedicated folder there, but please also yourself, so that you make sure that you have actually your files. So you can create here in the research, you can actually, to make things a bit more, let's say, coordinated, put it in the HUS data lake, scripts and users. So it will still be in the same. There would be a kind of a certain order in the if possible. If you want to have them here, it's fine, but please then create like a Kekalainen directory or something that where you have all your groups data so that this looks a bit nicer. Yeah.
Okay.
All right. Some other things. So if you would like to use Conda for anything, there is one Conda environment. You are free to modify that, or you can create a new one. The Conda environment is called Conda F, so you can activate that directly. But please, you can also create your own if you want, and you can store it in your home directory. If you don't know what Conda is, then it's probably not relevant. Well, then lastly, I'll maybe show. No, second, lastly, I'll show you again this file that I showed. So it's basically will be here in this. It's an HTML file. So this is basically the instructions to recreate the whole kind of a directory. All you see, you can recreate by reading these instructions. Not that long, actually. There is specific instructions for the Linux HPC, and if needed for the Azure ML. I'll show you in a moment what is Azure ML. Basically, you can just open a terminal, run these 2 lines of code, and actually 3 lines of code, and then you will recreate it. After that, if you run, follow these instructions, you will be able to do basically this step that is here. So change the raw data files into a nicer format. So this is the part number 2. And then after that, so this will take a few hours, the first step. It will take probably half a day to do the second step, but you don't need to actively use. You can do something else in the meantime, of course. And then lastly, if you want to use the RStudio, please run this in the terminal, and this will make sure that you have all the settings correctly. So you don't need to open, or you should not open it from here, but from the terminal, run this, and then go ahead. Here is a very brief description of the different folders that is, what kind of data there are, and then for the Spark, how to use it, and then if it becomes deprecated, how to basically keep it updated. So all the scripts basically to recreate the environment are here in the script build env. There is some basic data and log files that keep there. All the scripts to recreate the HUS data lake, different data sources. There are quite many of those. They are here. Please do not change them, or you're responsible for anything that is not working anymore after that. The launching script, there is also actually a bash script if you want to run an example how to use bash to run our script in the background if you would like to do that. Some few R functions for general use and so on. But everything that you have seen here at the moment is so far is for the Linux HPC virtual machine that you see now. And if there is the Azure ML here on the left, you can click that. It will open the browser. And then you'll get access to the Azure Machine Learning Studio or the Azure ML Studio. Here, you click on the first and only workspace you have access to, here. And here, the major things that you need to kind of know is the compute and the data. There are also other properties that you can use, but I would say that 99% it's related to either one of those. Compute, let's click it first. So you have the option to, or the possibility to Actually, I'll just start this now so that we can have a look at that in a moment because it takes some time. So here are all the computing instances, so the virtual machines that are in the Azure framework that you have that have been created in this environment, so in this academic environment. What that means is that you can create a custom computer with custom properties that you can use to do the analysis. So if you think that the environment you have access to do not have the correct properties, or you would like to have some more computing power, you can do this. How that happens is that everything is in the HUS IT instructions, but very quickly you can click on new. You will create that. You can put a name, let's say computer. Then you can define if you want only to use the CPU, also GPUs. This will become obviously much more expensive. So think wisely if you really need that. And then there are 4 kind of recommended options and their prices. And the default is to click this one, and I would strongly go with that unless if you have some really, let's say, if you need to get more power, maybe this one. But if you want to get, let's say, a really custom computer, you can have a look at what options there are here. And you can see that the number of cores, the number of RAM memory, and the storage memory differs. So you can just pick up anything you need. Okay, so let's say you go with that one. After that, well, you can just type create, but you can also, I would suggest to put here in the startup and shutdown schedule some rules when the computer should be shut down if you forget to do it yourself. So if you do not stop the instance after stopping your work, every kind of a hour will cost. So I will advise if you know that you won't be working after 5 o'clock in the afternoon, and you work only on the weekdays, you can define it like that, or why not put it on the weekend as well. And so that will then stop the computer if you forget to do that. So it's quite wise to put that there. When you create it, you can also add here a script, for example, this init VS Code or anything else, basically any bash code that will run at the same time that the environment is created. What this does is that if you would like to use Python or any command language, basically, using this Visual Studio Code here, you will connect to your computing instance automatically, which is quite nice property for some users. There is actually also don't remember where I have put it, but there is a specific code also to install the 700 R packages in the computing instance as well, so that you won't need to do it manually. So the 700 packages are basically the ones that I installed in the old environment, and it's kind of a list that most of the users will have need for. So then you can just type on create. I won't do it now because I have already created an environment here, which is now I have started it. So if then I want to stop it, I just click on here and stop. And so now it is running. And if I would like to use that, I can type, for example, if you want to use R or Python, you can type on JupyterLab. Unfortunately, there is no RStudio or POSIT at the moment, but hopefully will become at some point. And then you can also use the VS Code. And if you want to use the terminal, that is also a possibility. But how does that look like? So let's go here. I have recreated here the script I showed you before. You can recreate the identical work environment that we had in the HPC computer. So you have the same HUS data lake folder with the same data as I showed you. There is the same script folder with the R functions and whatever, and so on. So the script I made is really compatible with both the Azure ML and then the HPC Linux. So how to use R? Basically, you can let's say that you create a new notebook. So you click on the plus R, and there you can start. So you can see it here. That is the R cluster or R kernel. You can change it to Python if you want on the go. It's that easy, and just click on select, and you can start to look at where all the libraries are. They will show it here, and here again, if you would like to use the R libraries that are installed, so they will be here in the it will be actually here in library. So basically, this library here is I'll move it, but basically you can just click on lib paths, and library, and now basically you should have now access to all the 700 libraries R packages that are here. All right, so this is how basically you can use then the R, and there is a bit more power here as well. But obviously this is never as good as the RStudio, in my opinion. But basically, you can see you can use it as well. You don't have the same coding or auto completion possibilities as in RStudio, but it's quite decent anyways. The second big difference compared to the HPC is what the data is. So okay, here you have it all. Sorry, you have all the data here in Mounts, Research, HUS Data Lake, data. This is all the process data. So as this is a different computer than this HPC computer here, you can, so basically you see one computer here and one computer here. If you want to have data available here, you need to import it from here to here. Downloading is very simple. You can just click here and download, and then you can download to the other computer. But importing, for that, you need to go back to this Azure ML Studio, click on data, and create a data asset. It's a bit weird. There are good instructions in the HUS IT instructions, but I will show you again how that works. You click on create. You name it. Let's say you want to import your, let's say, immune dev scripts. You know that these are files. Yes, put always files here. Next, from local files, so from the local computer here. So it's the HPC computer. Then it's the workspace blob store. And then you can upload the files or the folders. So let's say you want to import, let's say these two files, or this folder and this file, whatever. Let's take these two files to make it simple. Click on open, and then it imports that. It's quite fast to import it, but if you have, let's say, many gigabytes of data, it will take a few seconds, maybe a few minutes. Then next, and create. And voila, it's done. And now to import the data, you need to also run the script, which is unfortunately in Python, but it's quite easy. I'll show you how. So here you have done that now. You go to consume, you copy paste this code, you go back to the notebook here, you change the kernel to not the first one, but one of the other 3 Python kernels. Click it, select, and then you copy paste the code, and you can run it like that. The only thing that you might want to change is here after the dot. If you put the dash, it will show you it should show the different. Okay, now it will basically install them in my whole folder. It's fine. Let's put it. Okay, you show now. You can optimize the path whatever you want. Let's say you want to put it in the here, for example. So it will come here. So then you can run it. For example, here on the play, run that, and then now it shouldn't be okay. It should come anyway. So if you look on the left side, I will click on refresh. That's interesting. Okay, now so now they have come here on the left side. So sometimes it gives these fail to extract, but I don't know why. It should always work. So we have now the new files here, and then you can move them whatever you want. However, if you would like to move them, I would recommend to use the terminal because it might be a bit slower to move them by hand if you have the possibility, especially for large data files. But now I don't need this, so I will delete them. So yeah. So on the plus, you can define what kind of a notebook. Well, console maybe not that useful, and then the terminal. But these are all in the HUS IT instructions. Please go ahead and have a look at them if you feel that this is useful for you. As said in the beginning, I do most, let's say 99% of all my analysis I do on the HPC. If I do something here with the Azure is actually what I will do is that if I want to do something with Python, I do it with the Visual Studio Code, and for some technical reason, the interactive extension does not work with the HPC backend, so I need to connect it to the Azure ML computer. It's actually very easy to do that, but this is one of the use cases, and the other one is if I want to analyze OMOP formatted clinical data. It's only available at the moment, to my knowledge, in the Azure ML. And then a third one is that if I want to do really some, let's say, really heavy computing, then I can use it. Of course, I can create a stronger computer to do that. And there are 2 options how to do that. One is this instance, which I showed you, and the other one is the compute clusters. I won't go to details, but basically what you do is that you create a script. At the moment, it only supports Python scripts, but after creating the script, you can import it here, or you change it to a job. So you can create a job from the script. After that, you need to make sure that you have an environment where you run the script. These are Docker containers, basically. And why the R scripts are not working at the moment is that there are no R environments, and creating the R environment is not that straightforward at the moment. We're looking into that. And then after that, you can create the cluster. So basically, we'll ask you what kind of a cluster you want to use. One very nice thing is that you can use the low priority. So if you're not in a hurry to get the results, these are really, really much cheaper. And this is especially relevant if you want to use the GPUs. You can use really powerful computers here at quite decent costs. And this is how our team will be doing the analysis in the Azure ML. So we will use the low priority machines, GPU machines here, and basically you can just create it quite fast, and then you can run the codes there by selecting the job, so the script, the environment, so basically the what kind of a Python settings you want or Python libraries you want, and then the cluster is basically connecting it to the computer itself.